Welcome to this explainer. I want you to imagine this scenario for a second. Let's say a military loses a multi-million-dollar, state-of-the-art supersonic bomber. The factory lines that originally built these massive, complex machines, well, they've been shut down for decades. You absolutely need to replace that lost capability to maintain your strategic edge, but obviously you can't just order a brand new one. So, how on earth do military logisticians solve an impossible problem like that? Today, we're diving into the really fascinating reality of modern fleet management, where the answer to a missing jet doesn't actually lie in a factory, but rather out in the scorching desert sands of an aircraft boneyard.
Here is the roadmap of the journey we're taking today. First, shrinking fleet, growing demand. Second, decoding Type 2000 storage. Third, the engineering resurrection. Fourth, validation and flight testing. Fifth, payload and arsenal capability. And finally, number 6, strategic mission impact.
All right, let's jump right into Section 1, Shrinking Fleet, Growing Demand. Why the U.S. Air Force needed bombers back. Okay, so let's set the stage by looking at the core logistical dilemma here. The U.S. Air Force currently maintains a relatively small fleet of just 43 B-1B Lancer aircraft. Now, managing this fleet has become incredibly complicated. In recent years, the Air Force suffered the sudden loss of multiple Lancers, and this wasn't to enemy fire, but rather due to non-combat mishaps. When your entire operational fleet is just 43 aircraft, every single airframe is a vital strategic asset. Losing even a few creates a massive gap in your global operational capabilities. Which brings us to that vital question. How do you replace a lost supersonic bomber when you literally cannot build a new one? You can't just run down to a dealership and buy one off the lot. This was the immense logistical challenge the Pentagon faced. They needed to restore their strategic bomber numbers, but their traditional supply lines were non-existent. They had to look backward to move forward. And this brilliantly illustrates the ironic twist in our story. Look at the number 17. Back in 2021, under a plan to cut costs and reduce the overall fleet size, the U.S. Air Force retired 17 B-1Bs and sent them off to the Boneyard. At the time, it was a purely financial decision, but ironically, that specific cost-cutting measure created the exact pool of mothballed aircraft they now urgently needed to draw from to replace their recent losses. Moving right along to Section 2, Decoding Type 2000 Storage. Let's look at the reality of the aircraft boneyard. We are heading over to the famous aircraft boneyard in Arizona. Now, when most people hear the word boneyard, they probably picture forgotten machines just rusting away in the desert sand, right? But Jet 860115 wasn't just dumped out in the desert to rot. It was placed in what's called Type 2000 condition. Basically, this means the aircraft is officially designated as a source for spare parts to support the active fleet. But, and this is the absolutely crucial part, it is preserved and maintained in a very specific way so that it could, theoretically, be restored to flying condition. So it's really not a graveyard at all. It's more like a meticulously managed organ donor program that intentionally leaves the door open for a full resurrection. But we have to make a really important distinction here. We need to understand the massive gap between flying condition and combat ready. Even though a Type 2000 aircraft is preserved well enough to eventually fly, that definitely does not mean it's ready for combat. Bridging that gap requires some unbelievably significant overhauls. We're talking about the installation of critical mission systems, advanced avionics, and deep, extensive structural repairs. Honestly, it's the difference between finally getting an old car to start in your garage and actually entering that same car into the Daytona 500. That takes us to Section 3, the engineering resurrection, rebuilding Bomber 860115. Turning aircraft 86115 from a preserved desert relic into a frontline heavy bomber required a massive, intensive engineering effort over at Tinker Air Force Base in Oklahoma. And this was no simple tune-up. Just think about this number, over 500. That is the sheer scale of the structural and systemic restoration we're talking about. U.S. Air Force technicians had to meticulously replace more than 500 distinct components on this single airframe. The mechanical complexity of a 4-engine supersonic heavy bomber literally cannot be overstated. Bringing it back from years of dormancy means you are essentially touching almost every single system inside that jet. And as you'd guess, it took a small army to do it. The 567th Aircraft Maintenance Squadron led this massive effort. We're talking about over 200 military and civilian personnel working together on this one plane. They worked extended shifts, day and night, just poring over complex system overhauls and extensive structural repairs. This was not a quick weekend fix. This intensive regeneration took a full 2-year restoration timeline to complete. 2 solid years of focused engineering just to get this one specific machine ready to breathe again.
All right, Section 4, validation and flight testing, how they took it from bare metal to mission capable.
So, once the wrenches actually stop turning, you have to prove the machine works. This is that crucial transition phase where the rebuilt machine transforms from a static engineering project sitting on a hangar floor back into an active, mission-capable military asset. Step 1, the 2-year overhaul at Tinker Air Force Base officially concluded in February of 2026. Then came the really dramatic part. Step 2. Test pilots took the bomber up for a functional check flight to validate all of its systems and performance. But the cool thing is, they didn't fly it looking like a normal military jet. They actually flew it in a totally stripped-down, bare metal configuration. Once it earned a clean bill of health there, it moved on to Step 3, hitting the on-site paint facility for a fresh livery before finally heading to Step 4, deploying to Davis Air Force Base in Texas to permanently rejoin the active fleet. Let's look at this whole journey from a macro level. Jet 860115 was originally sent to the Boneyard to save money in 2021. Now, interestingly enough, this jet is actually the second retired B-1B to be restored to active duty in recent years, with the very first one blazing the trail back in 2024. For our jet, the overhaul finished up with that bare metal check flight in February 2026, and on April 22, 2026, it officially returned to operational service. That is a full 5-year round trip from the desert right back to the flight line.
Which brings us to Section 5, payload and arsenal capability. Let's talk about the firepower of the restored B-1B.
Now that we know exactly how they did it, let's look at the why. Why invest 2 entire years and thousands of man-hours into this single airframe? Well, it all comes down to the sheer mechanical capabilities of the aircraft. The answer is 34,020 kilograms, or, if you prefer, 75,000 pounds. That is the staggering total weapons payload capacity of this supersonic bomber. There are very, very few aircraft on the planet that can haul that much weight that fast over those kinds of intercontinental distances. You simply cannot afford to lose that kind of capacity from your fleet permanently. And all that immense weight translates into some incredible tactical flexibility. Check this out. A single B-1B can carry an unbelievable 84 of the standard Mk-82 general-purpose bombs. If the mission requires a bit more precision, it can load up 15 GBU-38 Joint Direct Attack Munition guided bombs. And for standoff capabilities, it can carry advanced weapon systems like the Joint Air-to-Surface Standoff Missile cruise missiles. This single machine represents a massive, completely adaptable arsenal. Let's move to our final section, number 6, Strategic Mission Impact. How the B-1B is used in recent global operations. With a fleet of only 43 active jets, which now includes our resurrected 86115, the U.S. Air Force definitely does not keep these bombers sitting idle on the tarmac. Recent deployments perfectly demonstrate the bomber's extreme range and active role in current global operations. For instance, in 2024, B-1Bs carried out a massive intercontinental mission, flying nonstop from North America to strike targets in Syria. Furthermore, the fleet has participated in the recent U.S.-Israeli air campaign against Iran. So these aren't just theoretical capabilities on a spec sheet. These bombers are active instruments of global fleet management and power projection, constantly moving and operating across continents. And this perfectly brings our narrative full circle. As military reports note, and I'll quote here, the loss of multiple Lancers to non-combat mishaps in recent years led the Pentagon to pull retired B-1Bs back into service. It makes sense, right? When you have a machine that can carry 75,000 pounds of munitions across the globe completely nonstop, and you unfortunately lose some to ground or flight mishaps, the immense logistical effort of dragging a jet out of the desert and spending 2 entire years rebuilding it suddenly makes perfect strategic sense. So I want to leave you with this provocative thought as we wrap up this explainer today. As modern military aircraft become exponentially more expensive to build, and overall fleet sizes naturally shrink as a result of those costs, we are clearly entering a completely new era of logistics. Is resurrecting aircraft from the Boneyard, literally turning to the ghosts of the past, the ultimate key to maintaining air superiority in the future? It's a totally fascinating question about the intersection of engineering, economics, and strategy. Keep questioning, keep learning, and thank you so much for exploring this topic with me today.